So, you want to learn C++. That's fantastic. You're embarking on a journey into one of the most powerful and versatile programming languages ever created. C++ has a rich history and a vibrant future, and it's a skill that will open doors to countless opportunities in the tech world. Great choice. You've made a decision that could significantly impact your career and your ability to create amazing software. Despite what you may have heard, C++ is more relevant than ever. It's not some relic of the past. In fact, it's a cornerstone of modern software development, powering everything from high-end video games, pushing the boundaries of graphical fidelity and immersive experiences. The gaming industry relies heavily on C++ for its performance-critical applications, to operating systems, the very foundation upon which our computers run. C++ provides the low-level control needed to manage hardware and system resources efficiently, and financial systems. High-frequency trading platforms and banking software demand speed and reliability, making C++ the ideal choice. When you need top performance and control when every microsecond counts, C++ is the go-to language. It allows you to optimize your code for maximum efficiency. Professionals choose C++ for one reason: control. The level of control C++ offers is unparalleled. You decide how memory is managed, giving you fine-grained control over resource allocation and deallocation, and how your code runs. You have the power to optimize every aspect of your application. This guide will demystify C++. We'll break it down into manageable pieces, breaking down its core concepts, philosophy, and features like object-oriented programming, which allows you to structure your code in a modular and reusable way. And memory management. We'll explore the intricacies of pointers, dynamic memory allocation, and techniques for preventing memory leaks. By the end, you'll see why C++ is so powerful, and why it continues to be a dominant force in the software industry, and have a clear path for your learning journey. We'll provide you with the resources and knowledge you need to succeed. Let's get started. Prepare to unlock the potential of C++. C++ stands as a titan in the world of programming languages, and a cornerstone of its enduring power lies in its fundamental design principle, the zero overhead principle. This isn't just a catchy phrase, it's a commitment to efficiency and performance that permeates every aspect of the language. It dictates that you should only pay for what you explicitly use, ensuring no hidden costs bog down your applications. In essence, you don't pay for what you don't use. This means that features and functionalities that aren't actively incorporated into your code won't contribute to the program's overhead, leading to leaner, faster, and more resource-efficient applications. This contrasts sharply with languages that impose a baseline level of overhead, regardless of whether certain features are utilized. Unlike languages with mandatory garbage collectors or heavy runtimes, which constantly consume resources in the background, C++ offers a more direct and controlled approach. These managed languages often abstract away low-level details, which can simplify development but also introduce performance bottlenecks. C++ compiles directly to optimize machine code, bypassing the need for an intermediary runtime environment. This direct compilation translates to faster execution speeds and greater control over hardware resources. The compiler meticulously transforms your code into instructions that the processor can understand and execute directly. That's why it's the language of choice for speed-critical applications, where every microsecond counts. From high-frequency financial trading platforms to cutting-edge game engines and real-time simulations, C++ empowers developers to push the boundaries of performance. Think of it as building a race car from scratch, carefully selecting each component and fine-tuning every aspect for optimal speed and agility, adding only what you need for maximum performance. You wouldn't bolt on unnecessary weight or components that hinder your car's ability to accelerate and maneuver. Similarly, in C++, you have the power to craft highly optimized code that avoids unnecessary overhead. C++ gives you powerful tools, such as fine-grained memory management and direct hardware access to achieve unparalleled levels of optimization, but trusts you to use them wisely. This level of control comes with the responsibility to manage resources effectively and avoid common pitfalls like memory leaks and segmentation faults. With great control comes great responsibility. The power to optimize also carries the risk of introducing subtle errors that can be difficult to debug. You can optimize deeply, diving into the intricacies of memory layout, instruction scheduling, and cache utilization to squeeze every last drop of performance from your code. But mistakes can lead to bugs or crashes, highlighting the importance of careful planning, thorough testing, and a deep understanding of the language's nuances. Mastering this philosophy is the first step to mastering C++, unlocking its full potential and enabling you to build high-performance applications that stand the test of time. It's a journey that demands dedication and precision, but the rewards are well worth the effort. C++ introduced comprehensive object-oriented programming, OOP. OOP lets you bundle data and functions into objects, modeling real-world concepts in code. The four pillars: encapsulation, protecting data; abstraction, hiding complexity; inheritance, reusing code; and polymorphism, treating related objects uniformly. For example, a vehicle-based class can be extended by car and motorcycle, sharing and customizing features. Polymorphism lets you write flexible code that works with any vehicle type. These principles make C++ code robust, scalable, and maintainable. They're fundamental to modern C++ development. Let's see OOP in action with a simple player class. A class is a blueprint. An object is an instance of that blueprint. Example: class player, public std, string name, int health, void take damage, int damage, health =std, max, 0 health damage, std, count, name to tukva, damage, health is now, health, stead, endl. In you can create a player, set its name and health, and call. This bundles related data and behavior, making code organized and scalable. As projects grow, you'll create many interacting classes. This is the backbone of C++ design. Classes and objects are the foundation of object-oriented C++. Practice defining your own classes to model real-world entities. This is where C++ starts to shine. Inheritance lets you reuse and extend code efficiently. Create a base class like entity with shared properties, then derive specialized classes like player. Example class entity, public int xy health, void move int xa int ya, x plus equal sign xa, y plus equal sign ya. Class player, public entity, public std, string name, void print name, std count, name, std, endl. Now, player inherits position and health and adds its own features. In, you can set player's name, move it, and print its name, all thanks to inheritance. Change shared logic in entity, and all derived classes benefit. Inheritance is a cornerstone for building large, maintainable C++ applications. It saves time, reduces errors, and creates logical code structures. Mastering inheritance unlocks powerful design patterns in C++. Templates are a tool for generic programming. Write code once, use it with any type. Instead of separate functions for each type, use a template void, print t-value, sd value, endl. The compiler generates the right function for each type at compile time, no runtime cost. Templates also power classes like the standard template libraries. Example template class array tamarane, public int getSize, const return n, now or all from one definition. Templates make C++ flexible and efficient. Mastering them is key to advanced C++. They're the backbone of modern C++ libraries and frameworks. Manual memory management is a defining feature of C++. It's a core concept that sets it apart from many modern languages. Understanding how memory is allocated and deallocated is crucial for writing robust and efficient C++ code. This level of control allows for fine-grained optimization, but it also introduces the potential for errors if not handled carefully. And a challenge. Debugging memory-related issues can be particularly tricky, often leading to crashes or unpredictable behavior. It requires a deep understanding of how memory works and the tools available to diagnose problems. Unlike languages with garbage collection, which automatically manage memory behind the scenes, relieving the programmer of this burden, C++ gives you direct control over memory allocation and deallocation. You have the power to decide when and where memory is allocated, and when it's released back to the system. This direct control is facilitated through the use of pointers and specific memory management operators. Stack memory is fast and automatic. It's used for local variables and function calls. The stack operates on a LIFO, last in, first out principle, making allocation and deallocation extremely efficient. Heap memory is dynamic but must be managed manually with and. The heap provides a larger pool of memory that can be allocated and deallocated at runtime, allowing for more flexible data structures and object lifetimes. Forgetting to free heap memory causes leaks and crashes. These memory leaks can gradually consume system resources, leading to performance degradation and eventually, application failure. Example, let's look at a simple example of dynamic memory allocation using AND. This line allocates an array of 50 integers on the heap. The operator returns a pointer to the beginning of the allocated memory block. Here you would perform operations on the array, accessing and modifying its elements as needed. Remember, that is just a pointer. You need to dereference it to access the actual integer values. This is the crucial step where you release the allocated memory back to the system. The operator is used to deallocate arrays that were allocated with. Modern C++ makes this safer with smart pointers, which automate the process of memory deallocation, and which automatically free memory when they go out of scope, preventing memory leaks. This is based on the RAI, Resource Acquisition is Initialization principle. Prefer smart pointers. They combine control with safety, reducing the risk of memory leaks and dangling pointers. Understanding memory management is essential for any C++ programmer. It's a fundamental concept that underpins many other aspects of the language. For writing efficient, reliable C++, proper memory management leads to faster execution times, reduced resource consumption, and more stable applications. Embrace the responsibility. It's what gives C++ its power. The ability to directly manage memory allows you to create highly optimized and performant applications, pushing the boundaries of what's possible. Writing great C++ means following best practices. Use RAI resource management to object lifetimes, smart pointers and classes that clean up after themselves. Favor the standard library, use and other well-tested tools. Keep code clean, use meaningful names, short functions, and clear comments that explain why, not what. Consistent formatting improves readability. Embrace const correctness, used to prevent accidental changes and enable optimizations. Example, void print player, const player, and player const. These habits prevent bugs, make code maintainable, and set you apart as a professional. Good practices are as important as technical skills in C++. We've covered why C++ is powerful, its core philosophies, OOP, templates, and memory management. But to truly learn, you need to write code. Lots of it. Start small. Build a calculator, a text adventure, or your own vector class. When you get stuck, use online resources and join the C++ community. Mastery takes time and patience, but every project brings you closer. Keep building, experimenting, and learning. You've taken the first step. Now the journey is yours. Good luck.